Welcome to Per Class. In this tutorial, I will show you how to create a simple classifier, thresholding one feature. If a part of your task is simple and you see a separability of one of the classes, it may be enough to just apply a threshold manually. It is not always necessary to work with complex classifiers. Let's continue in our French fries example we used in the previous tutorial. This is a small piece of an hyperspectral image with 103 bands. We save the image as SD data and visualize the density plot per feature with sdfeatplot. We can see how the data is distributed in the different bands. In this band, we can observe I by modality. In the sdfeatplot figure, we may set the threshold interactively by clicking with the left mouse button. We save the pipeline and apply it to the image. Let's see what the decisions are. The pixels above the threshold appear to be the tray, while the ones below are the French fries. We name the decisions as tray and object and save the pipeline. We can now apply the pipeline to the whole image and identify the fries. And we may also, for example, select only a part of the data and work further with this reduced data. This is how we obtained the train detector used in the previous tutorial. Our goal is to sort the fries according to their goodness, removing the ones with defects. To learn the defects, we do have a training data with the labels of the classes of interest. This is the scatter plot. But let's look again at the data distribution. Now we have the class labels, so we can observe how the class distribution changes in the different bands. We may still use the simple threshold to create a classifier for the good part of the fries. We name the decisions above the threshold as flash and the ones below as bad. Right-click of the mouse gives us the context menu with two options for the confusion matrix. Let's compute the normalized confusion matrix on the training set. This helps us to get a feeling for the errors the chosen threshold makes in the different classes. The three defects, rot, green and peel, are mostly classified as bad, while 98% of flash is correctly classified. In this way, we can better assess if we are satisfied with the threshold or would like to adjust the threshold further. For example, let's say we would like to lower the false positive in the flash class. We can do it, and we verified that we correctly classify 97% of flash. We save this classifier as pflash, and now the classifier can be readily applied to a new hyperspectral image, for example our previous one, and we can visualize the results simply loading the pipeline. Summarizing, we have seen how to understand the data separability with a per-feature density plot distribution, and how to quickly create threshold classifiers by manually thresholding a feature in the distribution plot.